Okay, so here's 3 ways you can apply the right-hand rule. One way is if you want to find the magnetic field associated with a current going through a long straight wire. So if I draw a long straight wire here and a current passing through it, you wrap your hand around, you put your thumb in the direction of the current, which is, I'm not going to try to draw a hand, but it's in this direction. And then you wrap your fingers around the wire. And what you're going to find is that your fingers are going to be coming into the page up here, and they're going to be pointed away down below the wire in this case. Of course, they would be in the opposite direction if the current were going in the opposite direction. So that's one application, and that is finding the direction of the magnetic field around a straight wire. Another one would be, and this is the one that caused some confusion in class today, is if you have a loop of wire and you have a current passing through that loop of wire. The way to deal with this is you wrap your fingers in the direction of the current. And your thumb of your right hand will then point in the direction of the magnetic field through the loop. So in this case, the direction of the magnetic field through the loop and is going to be into the board or into the page here. If the current were going in the opposite direction, which I'll draw right here, and you wrapped your fingers, oh shoot, the current goes into the board. Excuse me, I just made a mistake there. So if you wrap your fingers in the direction of the current here, your thumb points in, so you're going to see the tail of the arrow. In the other case, when the current is going in the counterclockwise direction, your thumb is going to point out towards you. So that's the second application of the right-hand rule. So the third one is when you have a magnetic field, a uniform magnetic field, and you have a charged particle, a positive charged particle, let's say moving up through the magnetic field, and you put your fingers initially in the direction of the red vector, and then you bend them in the direction of the magnetic field lines, which are the black lines, and then the thumb then points in the direction of the force that the positively charged particle would feel. So in this case, and this is the one we went over quite a bit, and you had a quiz on it also, but in this case, the thumb would point into the board, so you would see the force that the charge experiences as being into the board in this case. All right, so those are the 3 places where I see the right-hand rule being useful and being applied slightly differently. Hopefully this will clear up any confusion you had. Good luck.